Hello everyone, welcome back to Quick Snips with Chris. Last week we celebrated the halfway point of Volume 2. This week we get to celebrate something else. You may not believe it, but we are finally done with space. After covering about 93 billion light years in 5 videos, it's time to move to, well actually that's kind of confusing. We're kind of moving everywhere. It's time to talk about matter, and also what state you live in. Oh, I see. It's the different states of matter. Matter is just what we call everything the universe is made of. If it takes up space and you can put it in a box, it's matter. Wait, can you put a car in a box? That would have to be a pretty big box. So the entire universe is made up of matter. But when we look around, there are a lot of different kinds of matter. There are soft things, hard things, mushy things. For a long time, humans have been trying to come up with names for the different kinds of matter. Have you ever heard of the 4 elements? Maybe earth, fire, air, and water? Oh wait, but what about stone, metal, earth, and ice? And what about lightning? What happens when there's hard earth, but also soft earth? And where do plastic sippy cups fit in? Now, we have a fancy schmancy periodic table, which tells us we have 118 different elements. And we'd better not find any more, otherwise we'll need a whole new table. The way it works is that each of these 118 elements can be found in any of the 4 states or phases of matter: solid, liquid, gas, and plasma. The state that you find an element in depends mainly on the temperature, pressure, and amount of energy that the element has at the moment. All of this goes back to atoms. Without diving too deep into atomic theory, particle physics, and quantum mechanics, atoms are basically the building blocks of all matter, and they have these electrons floating around them. Remember these electrons. They come back later. But let's see, the first state of matter is Texas. No, I'm sorry, this is the molecule of water made up of 1 oxygen atom and 2 hydrogen atoms in a solid state that just happens to be in the shape of the state of Texas. This solid state of water is what we call ice. When particles like these water molecules are arranged in a solid, they usually have a rigid pattern and they don't really move around very much. They just vibrate a little here and there. Okay, nothing much really happened there, so let's move on to the next phase. When particles are locked in a solid like this, they don't have much energy. When we add some energy to the system, the particles aren't stuck together anymore and they can move around a bit. Unfortunately, magic energy powder doesn't exist, so I'm just gonna have to turn on some Texas heat. Now I'm adding energy to this solid by adding heat. Goodbye, Texas! Now, as more energy is added to the system, this solid ice cube will melt into the liquid state of water. Cool, so we went from solid to liquid, but let's not stop there. If we take our liquid here and add more energy, it will transition to the gas phase, where the particles can really move around wherever they want. In this example, if you get the water hot enough, the molecules will actually split into hydrogen and oxygen gas. Back in the pan, as I continue to add energy through heat, you can see this liquid boiling and turning into water vapor, this gas that's coming up out of the pan. Now, I know you've heard this a bunch of times, but kids, don't do this without asking your parents first. I'm watching you. But what happens when you add even more heat? Well, it doesn't happen very often, but if you add enough energy, you can make a plasma. Remember these electrons from earlier? In a plasma, there's actually enough energy that the electrons come off of the atom and go whizzing around in a weird kind of soup. Really, the only time you can see plasma here on Earth are in neon lights or good old-fashioned lightning. So plasmas are pretty rare, but they're really cool. And those are the 4 states of matter: solid, liquid, gas, and plasma. That's 1, 2, 3, 4. But here's the thing. There's actually 5. There's always one more, isn't there? Turns out that when you get things really cold, I mean really, really, really cold, you get this stuff called Bose-Einstein Condensate, or BEC. At this temperature, it should be a solid, right? But it's not. It's, well, actually, we don't really know what it is, but it's definitely not a solid. We're still working on that. Some really interesting research about supercold substances is being done in the International Space Station that's orbiting the planet right now. See, space always has to sneak back into everything. Oh, wait, I actually think I have to go. I think they're calling me back to the ISS to work on some of that BEC stuff. Duty calls. See you next time.